Of this together for number 4. We had previously found a bunch of these characteristics with rational functions that didn't have slant asymptotes, but now we might have slant asymptotes. So looking at this one, I see it is degree 3 over degree 2. Since it's 1 degree higher in the numerator, we do have a slant asymptote, which means there's not a horizontal asymptote. So I'm going to go ahead and put none there. You don't have to do this in any particular order, but remember we should probably look for holes. So if I find a hole, we can go ahead and reduce it out. So to find a hole, I'm going to need to factor the numerator and the denominator. We have, let's talk about the numerator first. 5x cubed minus 40x squared minus 7x plus 56. This is one that we would need to factor by grouping, and so I can factor out a 5x squared and have an x minus 8 left over. I can factor out a negative 7 and have an x minus 8 left over, which gives me a common factor of x minus 8 times a 5x squared minus 7. So that's the numerator. That 5x squared minus 7 will not factor more. Let's look at the denominator. Denominator x squared minus 7x minus 8. This does factor as well. This would factor into x minus 8 times x plus 1. So writing our function in factored form, just kind of putting this together, this leads us to have y equals x minus 8 times 5x squared minus 7 and an x minus 8 times an x plus 1. We see we do have a hole, and it's happening with this factor x minus 8, which makes a hole with, or a hole at x equals 8. When we were talking about holes, we mentioned that the x coordinate is not enough information. We want the whole location. So let's look at what's left over. We have a 5x squared on, or 5x squared minus 7 on top, and an x plus 1 in the denominator. So if we want to find the whole, I need to evaluate that reduced function when x is 8. So 5 times 8 squared minus 7 over 8 plus 1. And we can use our calculator as well. 5 times 8 squared minus 7 is 313 over 9, which gives me roughly 34.777, so we'll say 34.8. Now typically I would want this as an exact answer, so you might say that this is exactly 8, 313 over 9, but that's really difficult to actually graph, so we will have to graph these functions, and you would estimate it's roughly around 34.8. All right, so I'm going to jump to that slant asymptote. This slant asymptote, I could do the division with the original function, so I could set up that long division, and I would still get the exact same quotient as if I set it up with the reduced one. Notice that the degree is still 2 over 1, which is bigger on top than it is on bottom, versus when I looked at the original, it was degree 3 over 2, exact same situation. So if you had done long division, x squared minus 7x minus 8 divides into 5x cubed minus 40x squared minus 7x plus 56. That same long division, or reduced, and x plus 1 divides into 5x squared plus 0x minus 7. Both are still going to give you the exact same quotient. So I'm going to do the reduced one. 5x squared divided by x would just be 5x. Multiply it through. And then we subtract that whole row. We end up with negative 5x minus 7. And we're going to do our division again. We have minus 5. So negative 5x minus 5. We subtract that whole row. And we have negative 2 left over. What matters is the quotient. So 5x minus 5 is the slant asymptote. Looking at the denominator, we had a reduced fraction of x plus 1 in the denominator, so I can find the vertical asymptote. It's at x equals negative 1. We can find our x-intercepts and our y-intercepts. So to do the x-intercepts, this was when the function was equal to 0. So I'm going to use the reduced function. I would multiply this x plus 1 times 0, but 0 times anything is going to stay 0. And then we solve for x. So I add 7, divide by 5, so 7/5 equals x squared. I'm running out of room down here, but it would be plus or minus the square root of 7/5. We do get 2 x-intercepts. So one of them I would list as negative square root of 7/5, 0. And then we have a positive square root of 7/5, 0. We could find the decimal approximation if we're trying to graph these. All right, we need the y-intercept as well. That's one of the easier ones to do because this is just plugging in 0 for our x value. And I can do this with the reduced one. I get negative 7 on top over 1, which is just negative 7. So our y-intercept is at 0, negative 7. And we need the domain. The domain of the function thinks about our denominator, but we can see that the whole removed an x value from the domain and the vertical asymptote is removing an x value. So I would have negative infinity up until negative 1, union, negative 1 up to 8, union, 8 to positive infinity. And we have one more page that's talking